Be aware that when the term decomposition is used, that it literally breaks down, without the addition of anything new. The thermal decomposition of limestone is not, I repeat not, combustion, as combustion is providing heat to something to make it react with oxygen, where the reaction overall is exothermic. It is a specific term, so don't use it loosely. Calcium carbonate thermally decomposes ionically, whereas long hydrocarbon chains thermally decompose covalently. Concrete is so strong as it contains calcium carbonate, an ionic compound. Ionic bonds are strong because of the attraction between ions of opposite charges. Water also does a great job of dispersing powdered calcium carbonate, so it can form a mixture which behaves like a liquid, so can be set in any shape which is needed. Some water reacts in the limestone reaction cycle, and some doesn't. The water that doesn't evaporates, leaving solid concrete. This is why you are asked not to step in concrete until it's dry. Electrolysis is used for the more reactive metals, which take advantage of ionic compounds found in ores, and separate positive and negative ions. That brings me to the reasons why the metals are reactive in the first place. Because the group 1 and 2 metals only have 1 or 2 electrons in their outer shell, they can very easily give them away to form ionic compounds with water and oxygen to form hydroxides and oxides. They react very fast with almost anything. Metals with more electrons in their outer shell can also be very reactive. If we really wanted to, we could displace oxygen from an ore such as aluminium oxide with carbon, and we would get pure aluminium, but the reaction is very dangerous, so electrolysis is used instead to separate them into ions. You may also be wondering why carbon is used to displace oxygen from an ore containing oxygen, but not for a sulfate ore, which instead uses oxygen to displace the sulfur. This is because if carbon was used to displace sulfur from an ore, a gas called carbon disulfide, CS2, will be produced, which is a very volatile gas and can be dangerous to deal with, so oxygen is used as it is much easier, since sulfur dioxide stinks but isn't as dangerous. I'm sure you know the gist of distillation, but allow me anyway. Crude oil contains a mixture of different hydrocarbon compounds, some of which have higher boiling points than others. The ones with higher boiling points will remain liquid or mostly liquid at higher temperatures, where those with lower boiling points are mostly vapor/gas, where they are then separated. The reason a column is made to get cooler at the top is because at the top, one hydrocarbon will still be a vapor/gas at a cool temperature because of its low boiling point, whereas the other is still mostly liquid, allowing for easy separation. This also features the less dense gas rising while the dense liquid falls to the bottom of the column. It is interesting you know that catalytic converters are called that because they literally are catalysts. They don't instigate a reaction but instead speed it up. Carbon monoxide and nitrogen oxides will naturally react with one another, but when the gases are forced through the small spaces in the honeycomb structure, they are forced into contact with one another under high pressure, thus causing way more reactant to react, and thus leaving less or no carbon monoxide and nitrogen oxide. Thermal decomposition is what happens when a substance is taken way past its boiling point. For example, the boiling point of pure decan is 174 degrees, but decomposes at 500 gas. Like I said, this is completely different from burning a hydrocarbon with oxygen, which is how fuel is used. Heating it extensively without oxygen will thermally decompose it. Carbon monoxides are produced with limited oxygen, not no oxygen. Longer hydrocarbon chains have higher boiling points because more energy is needed to make heavier and larger molecules accelerate fast enough to transition into a gas. Don't forget that higher temperature substances just have their molecules moving around faster. As you know, hydrocarbons release energy upon burning them because the reaction is endothermic, and because the energy produced from forming the new bonds is more than that which is needed to break the old ones. It makes sense why energy is needed to overcome bonds and break them, but why is energy released from forming them? Because the energy that was used for an atom to repel another atom, due to the outer electrons on both repelling each other, is basically discarded so electrons can be shared, releasing energy. Remember that to repel something is a force, so if an atom is repelling another atom, It is accelerating the other atom away from itself. When this kinetic energy is released, the surrounding atoms move more because of absorbing it, hence heat is attained and the surrounding temperature increases. The fact that unsaturated vegetable oils contain double bonds and saturated oils only contain single bonds is confusing to some. In a chain, any carbon that isn't on the end of a chain can hold up to 2 hydrogens. So double carbon bonds will result in them only carrying 1 hydrogen. To be saturated with something is to hold as much of it as possible. A double bond means the carbon atoms are not holding as much hydrogen as they could. You may also have been wondering why oil and water do not mix. This is because of a quality called the heat of mixing, which can be positive or negative, which is an energy which needs to be given or taken. The heat of mixing relates to repulsive or attractive forces in a molecule which need to be overcome, and 2 substances can only mix if they satisfy the heat of mixing of the other, which often works where one has a negative heat of mixing and the other positive, where the positive can take the energy it needs from the negative with no problems. This is why some substances have no problems mixing, and is why distillation columns exist, yet oil and water have no problem not mixing and need emulsifiers to mix. How convection currents beneath the crust work is quite interesting. Magma closest to the core will get massively heated up, and get less dense and rise towards the surface, but will then lose a lot of that heat, and will then get displaced by magma which is hotter and less dense which was more recently by the core, and as a result get pushed back to the bottom in a cycle. I am now going to go into some hardcore atomic theory, so hold on to your butts. If protons are positive, why don't they repel each other in the nucleus? They do. There is actually another force called the strong force which holds the nucleus together. I don't need to go into details about it, but just know that protons do actually repel each other. You may also be wondering why the proton is used to assign the element an atomic number if there are just as many electrons for an anion. The proton is the most important for the following reasons. Electrons can be removed very easily, whereas it is extremely difficult to remove a proton from a nucleus because of the strong force. Even chemical reactions only redistribute atoms, but internally the atoms themselves and nuclear are untouched. Furthermore, and for this reason, the number of protons determines the number of electrons at a neutral charge, so in that respect dictates the overall charge. This is also why neutrons aren't used to distinguish elements. Because protons are positive and neutrons are neutral, protons have more influence over the atom for these reasons, where protons add mass and dictate the number of electrons needed for a neutral charge, and neutrons just add mass. You'll also find 2 samples of the same element with the same protons and different numbers of neutrons are exactly that, the same element. The neutron number doesn't affect its chemical properties at all, and only matters in nuclear reactions. This is an important thing to take in. Chemical reactions don't affect the nuclei of an atom. They affect where the atoms go and how electrons are paired up. Sincere apologies if that was too physics. Just kidding, fundamentally chemistry is physics. Covalent bonds are found because elements with similar numbers of electrons in their outermost shell share with each other, so both can have 8 electrons in the outermost shell so they can be stable. This doesn't include reactive metals which can just give them away so much more easily because they only have 1 or 2. This is also why metals like aluminium are reactive, but not as reactive as group 1 or 2 metals which have 1 or 2 outer electrons. Aluminium has 5 outer electrons, so we'll have a harder time finding a compound which will take all 5. Poor guy. You may also be wondering why there are only 2 electrons in the first shell. This is because gravity is strongest closer to the nucleus, so the electrons are pulled much closer together. Because electrons repel each other, especially at closer distances, there are only 2. Because of being closer to the nucleus, the circumference of the orbit is small, and the distance between electrons when opposite each other is smaller than electrons in outer shells which aren't opposite each other. Even though the difference in distance seems small, because the first 2 are closer and held down by gravity, it makes a big difference, so outer shells can hold 8. You may also be wondering why different bonds have different energies. A CC bond will have less than a CH bond. Why? Here's why. In covalent bonds, electrons get shared. Between bonds with two of the same element, the electrons are evenly positioned, but when both atoms are from different elements, and one has more protons in it, it will pull the shared electrons slightly towards it as the nucleus has a stronger positive charge. This makes the positive atom overall slightly negative and the other slightly positive as the electrons are closer to the one with more protons. I say slightly, it is nowhere near as much as an ionic compound. Because one is slightly positive and slightly negative, they will be attracted to each other. The extent of attraction depends on how many more protons one has than the other. The result of this is that it needs more energy to break, and gives out more when formed,